The next one we are going to see is Petersons Olefination. From the name itself, it's actually an olefination reaction. You can see that this reaction will take place in presence of acid or a base. So you can see that it is a trimethylsilane. Trimethylsilane compounds in presence of a base or an acid, it will undergo elimination and forms an alkene. It is called Petersons Olefination. This reaction is called Petersons Olefination. You can see that the reaction happens in presence of acid or base. Let us see the process. So this is the derivative trimethylsilane compound. This compound on treating with LDA or THF. LDA is, is actually lithium diisopropylamide. It's a very strong base. It's actually a very strong base. Lithium diisopropylamide is actually a very strong base. So what can happen is that the base will undergo deprotonation. Base will prefer deprotonation. Base will actually prefer deprotonation. As a result of deprotonation, a enolate like this is formed. It forms enolate like this. Compound is formed. This will add to a carbonyl compound. You can see that it will add like this. And it will go like this. And as a result of that, a new bond is formed between this carbon atom and this carbon atom. A new carbon-carbon bond formation takes place. So we have got the R1 and R2. O become O minus is here. And you can see this bond is here. You can see that this adds to this carbon atom. And we will be having Me3Si here and COM is there. Already there is a hydrogen atom extra here. It will be adding here because it is H2. Now what can happen is that there is this adduct is actually an adduct. This negative charge, it can add to the silicon and it forms actually a complex like this. Okay, and next why silicon is taking, because silicon is having the vacant orbital to take the lone pair negative charge and the oxygen atom. Next step, what happens is that this bond shifts towards this place, and this bond shifts towards this place. As a result of that, a new carbon-carbon bond is formed and gives off minus Me3SiO. Is giving out or is going out. Okay, it is actually formed. Normally, we get a mixture of E and Z olefins here. This reaction is called Petersons Olefination. This reaction is called Petersons Olefination. So it's actually a very important reaction for the synthesis of alkenes. So in Petersons Olefination, we have got trimethylsilane compound. In presence of base, it forms an enolate. Okay, that compound may attack a carbonyl compound. It's actually nucleophilic addition to the carbonyl. And later it forms a cyclic intermediate from where it undergoes elimination, just like that of the Wittig reaction. Okay, it undergoes elimination to form Me3SiO and it forms this alkene. And we get normally a mixture of E and Z olefins. Another example of Petersons Olefination is this. So again, CH2. This is actually CH2. This thing in presence of a magnesium, you can see that it forms a Grignard reagent. This will add to the ester. You can see that when it adds to the ester, what happens is that there is double bond here. There is this will be adding. This part is plus part. This is the minus part. The minus will add here, and it forms this adduct. And MgA will go to the oxygen atom. So there's OMgA, there's ROMe, and there is a new bond formed between this carbon atom and this carbon atom is negative charge, this carbon atom and this carbon atom. So there's a new bond formed here between this and this thing, and Me3Si is here. Now what happens is that there is olefination. There will be removal. Again, there will be removal. There is actually a bridge formation between this lone pair and the silicon. Later, it undergo elimination process like this before, and will get you the alkene. This reaction is actually called as Petersons Olefination. This reaction is actually called Petersons Olefination. Okay, so another example of Petersons Olefination is this is the carbonyl compound. This on treatment with the orthohexyl compound in presence of tertiary butyl Me2SiCl. Okay, this compound will undergo elimination and it gives you this compound. This can give you a shift-based like compound. Okay, and the reaction can undergo like this, and you can see that this will act in presence of acid and the base. It will give you different products. It's a bit complex process, but I just want to mention that only. Okay, I will give you another example. Okay, so you can see that it is found that the reaction will take place in presence of acid and a base. Let us consider this reaction. Okay, this is actually a saline. Okay, this compound in presence of acid. Okay, acid is there. There will be two lone pair in the oxygen atom. It gets protonated. As a result of that, there will be OH2 plus C3H7, and here we have got hydrogen, and here we have got Si-Me3. There is C3H7 and there is hydrogen. Okay, now what happens is that if you got water will attack this system, and what happens is that this will go like this and it will go like that. As a result of that, we get an alkene. H is there, and you can see this is, here we have got C3H7 double bond. There is H here, and there will be here C3H7. It's actually a trans product or the E alkene. So in presence of an acid, E alkene is formed. So it is actually, therefore, it is actually acid catalyzed Petersons Olefination. It's actually, therefore, acid catalyzed Petersons Olefination. The reaction is slightly different if you use a base. Okay, so base, what happens is that, if it is a base, in presence of a base will uptake proton. So, H, there will be there, and, there will be C3H7, and it's actually, sorry, like this. And you can see that here it will be Si-Me3. Its carbon atom is O minus. We can see here this C3H7 and H. Now what happens is that so oxygen has to attack the silicon atom. So for that, they should be in C3H7, and here it should be like that. So what should happen? This should rotate. And when it rotates, the silicon Si-Me3 should come up. Okay, when it come up, what happens is that this will become, H will be here. And when it rotates, in rotates, it will be getting like this, and here will be C3H7. Now what happens? O minus here is there, and it will go under elimination later. It undergo elimination, and it forms actually a cis alkene. C3H7 here, C3H7 here, there's hydrogen here, and hydrogen here. It's actually a cis alkene or Z alkene. So you can see that, and on base catalyzed base catalyzed Petersons olefination. It's actually base catalyzed. On base catalyzed Petersons olefination, you will be getting Z product. But in presence of acid catalyzed Petersons olefination, we will be getting the trans product. So that's the difference in the Petersons olefination. These are some of the examples of Petersons olefination. Thank you very much.